Good morning, YouTube. Got us a little Goodman here today. It's only 10 years old and the compressor's dead. We're going to convert it to R407 and install a new compressor. I'm going to pull the top off and put the gauges on it and show you how I determined that the compressor was bad. Okay, I got the gauges hooked up. Got a standing pressure of about 104. It's fairly cool out here this morning. Probably not 60 yet, or maybe right at 60. I put my temperature clamps on the suction and discharge of the compressor, and I'm gonna go over here and fire it up. Okay, she's up and running. Sounds a little weak. About an 8-degree difference between the suction and discharge right now. It's actually pumping down a little bit right now. Something gives way in it and it'll quit pumping altogether. Of course, you can kind of hear the rattle. It's cool to the touch. When I came out the other day to check it, it had been running, and of course was just sitting here churning, wasn't doing a thing, wasn't any kind of a pressure difference at all again. So today she's actually pumping a little bit, but I'm not sure. Like I say, it sounds like something's broke in it. The Freon is not acidic. The R22 is not acidic. So I don't think, of course, it isn't burned out. It's running, but it just won't pump. As you can see, it builds up a little heat just from the motor actually running inside the closed vessel there, but it's not pumping, or at least it's not. I think most of that pressure is just coming from the heat. So I'm going to recover this refrigerant and get this old one cut out. Okay, got the recovery unit running, getting the R22 out of the system. Here's what I'm going to go back with. This is a thing United Refrigeration puts together. I'm sure a lot of you guys have seen it, but you haven't. It's an OEM pack. It comes with the compressor, enough capacitors to do whatever you need to do. Bi-flow dryer. I'll open it up and we'll take a look at the inside. Contactor. I think it has a listing on the back. Yeah. See, the first line item is a fan capacitor, 7.5 and 10. Of course, this one has a 5, but you notice the compressor capacitor is a combo 25/5, so that's the only one I will need. So I'll have me a 7.5 and a 10 to put on the truck for another job somewhere. Wiring harness, contactor. 2-pole, I'll have to look. If this one has a crankcase heater, we might need a single pole. We'll have to look at it and see. Some copper. Comes with a crankcase heater, so maybe they want to leave it on all the time. We'll look at it. Dryer, acid test kit, and a reference guide. I've not seen the reference guide. We'll take a look at it. One thing about your capacitors when you are working on one, especially if somebody's been there before, don't just put the same capacitor back on it. Of course, this compressor takes a 25. I've looked it up on Copeland's website before I bought this. And the fan motor will tell you on it what it needs. You can see this one says it uses a 5 capacitor. I went out to a job on Sunday and they had no AC. It was a pretty hot weekend here. The outdoor fan motor would not come on when they turned it on, and I gave it a twirl and it took off kind of slow. So I checked the capacitor and it had a 45/5 capacitor in it. So I looked at the fan motor and it called for a 7.5, and that's a big difference in what it needed. So always check, especially if you think somebody's been there before. One thing I get questions about a lot of times by private message on YouTube, when you change the compressor and go to 407C. Everybody wants to know, did you change the oil? Well, all the new compressors are coming with POE oil. So you need to confirm that it is a POE oil compressor before you just assume it is. But unless it's been sitting on the shelf for a while, it's going to have POE oil in it. We'll see if you can hear me over this recovery unit. As you can see, this compressor is a CR14. You typically think that's 14,000 BTU capacity. It has mineral oil in it. The way you can tell on most of these if it's a mineral oil or a polyester oil is they put an E in the part number. I haven't opened this one up yet, but that existing compressor had a capacity of 14,100 BTUs in a heat pump condition. The new polyester oil compressor, the one that has the E in it, if you buy the 14, it's going to have a capacity of 13,800 according to Copeland. Now this one is an 18, which of course everybody would recognize as being a 1.5 ton. But if you look at the actual data on it, this 18 with the polyester oil has a capacity of just under 14,000 BTUs. If you went to again a 14 compressor that came with polyester oil, you would drop down even lower than that. And since we're using 407C, we're going to have a slight reduction in capacity anyway. So this 18 turned out to be the right compressor for the job. Let's see what's in the box. Again, you can see the E in the model number, K6E. That designates that it has polyester oil in it. You can see they've changed it to a molded plug like most of the Scrolls have. That's why they included the cord, I imagine. Got a little bit of copper, looks like some 3/4 and 1/2 inch copper. We have a 16 size bi-flow dryer. Here's your compressor component kit. You got your new isolation bushings, your new cord, pigtail. Got a few fittings. And looks like a wraparound crankcase heater. I assume this is going to be all of our capacitors and contactors. Okay, there's the old valve cores. Got them all out. What I've got to do here, as you know, Goodman sells to a lot of people. You can buy them online. A lot of people get them and put them in that shouldn't be putting them in. So one of the things Goodman does to try to protect herself is they put the liquid line dryer on the inside of the unit so it makes sure it has one. A lot of manufacturers bundle it separate where you can put it out here and be able to get to it. But Goodman's afraid some of their contractors would not install the thing because it would be an extra step. So it makes it kind of rough on us guys that come out here to work on something. I'm sure you came up to a Goodman and found a liquid line dryer out here and you look inside and the old one's still there because it's kind of a pain in the butt to change. But what I'm going to do, since we're got it open anyway, I'm going to pull the control panel off and bend it around, or maybe even unhook a couple of wires inside and move it all the way out. And I'll take this cover off, and that way I can get in here to it easy. This one does have a crankcase heater. It's the old insertion type. Hooks up on these two little gray wires. So what we'll end up doing is putting our new crankcase heater on and hooking it up in the same fashion. I haven't looked at it yet, but depending on where those little gray wires go, they're either keeping it on all the time, maybe they're black, either keeping it on all the time, or they're going across the contactor. But in this case, you can see both of these wires come to the bottom of the contactor, so they're heating the compressor all the time. So that 2-pole contactor will be fine in this case. I'll go ahead and use it, hook my crankcase heater up the exact same way it was from the factory, and everybody will be happy. Almost made a rookie mistake. Reach over and grab my dikes. I was going to cut these wires instead of fooling with that cover, and I just happened to glance over at the disconnect. I turned it off on the inside and had not pulled the disconnect out. So a moment ago when I was fingering those wires, it could have been bad. That would have probably got more views. Okay, got the compressor out. Ordinarily I would cut these things out. This one's kind of tight. They put this suction port right here next to the compressor, and of course you can see the little loop on the actual muffler there. So since it wasn't a burnout, I just float nitrogen in. It didn't even flame up or have the phosphane gas like you would normally have when you can get that nitrogen flowing through it good. It takes all that out of the lines before you get it good and hot. So what I'll probably do is go ahead and get this dryer out of here. I'll cut it out. I've got room, I think. I'll probably cut the actual dryer on the actual dryer stem, get it out of there, and then heat up this sleeve that come out of the dryer and pull it off the line. You don't really want to heat a dryer up, because if there's anything trapped in it, it's going to bring it out. So I'll get that done, and before we go back to this compressor, I'll try to clean this stuff out. I looked for a water hose, but there's no place to hook one up, so I'm just going to have to clean it up the best I can. The coil looks pretty good looking through it, so I think we'll be okay if we just sweep the pan out and get the new compressor set down in it. Here's what I was talking about on the dryer. I'm going to actually cut it. See if we can get the light. I'm going to cut it right here down next to the actual metal casing of the dryer, and then I'll heat up this sleeve and pull it off of there after the fact. That way I won't get this dryer hot. And then I'll turn it over and cut the bottom off and do the same thing. Put me back a piece of copper where the dryer used to be inside the unit, and then I'll come out here and put me a new dryer. See where I've cut it loose out here? I'll put me a new dryer right here. By taking this one screw out of this service valve, it allows you to have a lot better room. You don't have to try to get in here and solder where it's kind of tight, and a lot of stuff you could hurt. Plus a lot of leaves you could set on fire. So I'm gonna get this cut out, and I'll cap this off, lay this over to the side. I've got caps on my lines in here, and I'll sweep all this up and get it cleaned up before I start going back. Okay, our dryer is cut loose, and as you can see, there's the thing that's still on there. And you're thinking, how am I going to get that off without oxidizing the inside of the pipe? What I'll do is I'll take this little service port. You can see I've used it before. It's got tape on it. I've got it swedged up. I'll slip it over the other end of this thing, and I'll flow nitrogen through it while I heat it up and remove the rest of the dryer off this pipe. So we have our nitrogen flowing through it, coming out the end. I'll have to lay the phone down to do this, but what I'll do is just heat up that what looks like a coupling now. In most cases it'll drop off. If not, I've got my channel locks laying there to help it a little bit once I get it heated up. And once we get that off, we just take our Hillmore swedger and make us up a little piece of copper that would be the same length as the original dryer. I'm just going to swedge it up on both sides so we can put it back in place of the internal dryer. And to make life easy on you, you can actually do one of the braze joints out here where you can get to it good. I just laid it on top of the old compressor. Of course, protect your valve with a wet rag. And fire it up. And we'll go over. I've still got to flow nitrogen back into the system and take off the other stub. And then I'll go ahead and put this one on while we're flowing nitrogen the other direction. And get this put back together before we start putting the compressor in. Okay, protecting my pressure switch with a wet rag. Got the nitrogen flowing, and because I have the other ports plugged, I'm getting nitrogen out right here where I'm going to heat this up and pull it off. And then when that piece falls off, you can slip your service valve assembly back up on there. And of course it kind of stuck anyway since it was still hot, but I will warm it up, flow a little solder around it, and we'll be done with this situation that would never happen if they didn't put the dryer on the inside of the unit. Okay, got the outside dipped out best I can. Got a lot of stuff in it. What I'm going to do, I'm going to go ahead and get this compressor in, and I may be able to get some water around here in a few minutes, they said, so I'll check on to that. But this compressor looks like it's going to fit right back in. Put my feet in, wrap the crankcase heater around the bottom. You want that probably no more than about 2 inches above. You want it to be down in the oil, at the oil level, so it can keep the oil warm. Of course, these units will come with these little sleeves to go in the rubber grommets, but if depending on the boat that's with your unit, you may or may not need them. In this case, I won't need them because these boats have shoulders already made on them. So I'm gonna set this over in there and see if I can get it lined up. Okay folks, she fit in there like a velvet glove, everything lined right up. So the only thing I haven't done, I haven't put the bolts in. I'm just letting I just got finished brazing that last joint, but I always put the bolts in last. That way you can use the compressor to keep some tension against these things to keep them from popping out on you and things like that. But I can slide it over now, twist it around, get my 4 mounting bolts put in, and then what I'll do is jump over there. I always put the dryer in last, right before you start pressure testing and vacuuming. You don't want to leave that thing open to the air. So I'll jump over there and get it brazed in and get a pressure test on this thing. Then I can start putting it back together while I'm waiting on the pressure test and the vacuum. Now I've changed a lot of blower motors where the line set's been in the way, but this is the first time I've ever changed the contactor where the line set was in the way. But I like this contactor they sent. It's got lugs on both ends, so I didn't have to crimp anything on the compressor leads. I can just put them under the lugs. I did have to crimp, of course, one on the get back here where I can see, on the start winding, so it'll go up here on the new capacitor. Pressure test still on it, but it held, so I'm gonna get ready to start a vacuum, and then I'll start picking up and start washing this thing down. The vacuum's going great. I'm going to slip my gauge back off and let it run for a while I wash it out. I just wanted to check. I always like to check before I start running water on it to make sure that it's holding. Don't want to suck a bunch of water in it. So what I'll do is take my gauge back off, let the vacuum pump continue to run. I've got it over here out of the way, and I'll get that water hose they've got me and wash this thing out good. Okay, got her washed out good. I found some little paver bricks out front and stuck up under to raise it up some so I could keep the drain hose clean, hopefully. I think it just filled up with leaves, and then the drain hose plugged, and then water laid in there and rotted the leaves, and it turned into dirt. And fortunately, they're putting the accumulator up on its own little shelf now that gets it up out of that debris. A lot of the old good ones used to be right on the bottom, and they would rust holes in the bottom of them pretty easy. So we're down to 250 microns with the pump running. I'll valve it off here in a minute and make sure we don't rise up, and if we don't, I'll be ready to put some gas in it. I think I'll let the vacuum pump run while I put the top on, though. I can go ahead and do that now and get it wired up, and then we'll be ready for some 407C. Okay, got the top back on her screwed down. I've had the pump off for a little bit, and she's still holding down below 300, if we can see that. Was it 260? It actually dropped 110, didn't it? So I think it's a successful fix as far as the refrigeration being tight. There's no leaks in it anywhere. So what I will do is get my scales and weigh in the 407C. I'll look and see how much the unit's supposed to have in it, and I'll start out about 80% of that. But in my experience on most of these units, I'll wind up with about the same amount in it by the time I'm finished. But we'll see how it goes. I'll get back with you when I get some refrigerant in it. Okay, I got 7 pounds in her. I just flipped her on, so she's going to drop down and then hopefully start building back up. But she sounds a lot better. She's pumping down a lot lower than the other one would. So we'll let it sit here and build some heat. And we should have to add up to 1 more pound, but I don't want to overdo it. So I'll check back with you in just a bit. Okay, it's been running long enough to stabilize. Got a superheat of about 18 based on the indoor wet bulb, which is only about 54 degrees, and it's about 70 degrees out here. We need to be down about 7 on our superheat, so I'll need to add a little more refrigerant. Again, it calls for right at 8 pounds, probably with the line set, and I put 7 in it to start with, so it's probably not going to take the whole pound to drop that superheat down, so it will take a little less on this particular one. We got a set point of about 8 degrees right now, so I think it's going to be a good repair. I got my sticker on it down here so that the next person will know what's in it. But I'm gonna go ahead and add just a little more and see if we can get that superheat to come down, and we'll wrap things up.